folks, and welcome to the latest installment on their Panzer project. So as you can see, we're back in the office here, and we're going to be doing for the next few videos quite a bit of electronics. So in the last installment, just after Christmas, you guys will have seen me installing the mechanical drivetrain in the car, so the motor, the gearbox, drive shafts, couplings, all that kind of thing. And you will have also seen where I made up some mounting brackets for the motor controller, which is what we have on the bench here in front of us today. So let's have a little bit of a talk about what we're doing here and the direction that I'm going to be taking. Now, as I mentioned in some of the previous videos, we're using our Siemens motor in the Panzer project, and I also had the option to use the plain as is DMOC 645 motor controller. And you guys will have also seen me building the open source inverter based upon the designs from Johannes Hufner. And we ran the Siemens motor on the bench, and we ran it connected up to the 5HP24 automatic gearbox, etc. But the time is now upon us to build the controller that will go in the car. And I have been, for the past few weeks, kind of rattling around in my head which direction that I wanted to go with this. I could purchase from EVTV a JEVCU, which is the Generalized Electric Vehicle Control Unit, which would issue the CAN bus commands to power this inverter as it stands, and that would no doubt work perfectly fine. But a few reasons that I've decided not to go down that particular path. One would be there's a good few other people doing that, so it kind of doesn't need me to get in there to kind of validate that particular process. Secondly, I hope to be able to run a bit more power into our Siemens motor than the basic stock, shall we say, version of the DMOC 645 could produce. We could have used the inverter that I built up, that I've been doing the various tests with, but it was a bit messy. I really put it together in a hurry just to validate. Well, I was actually quite surprised that you could run a AC motor in a closed loop system with just this little simple card. So I guess I really wanted to see if that was feasible. So I didn't exactly worry too much when I was building that particular inverter. Nonetheless, it has performed quite admirably on the bench without any problems at all. So what we're doing today, folks, going back and forth on myself a little bit. One other reason for not using the original DMOC is there, and I'll show these to you as we go through the process. For example, the control board is a very highly integrated card, as is the gate driver card here. There's a lot of components I saw just on a very first glance when I looked into this inverter, and we'll look in more detail, of course, as the video series progresses. at some of these cards, but there are I would imagine quite a few difficult, if not impossible, to purchase electronic parts used in the design of this inverter. And that would quite simply, in the event of a failure, pretty much leave me high and dry, other than perhaps being able to purchase another DMOC 645. So the flip side of that being that these cards here for the let's call it the open source inverter, they're very basic cards. They're all true hole, with the exception of the kind of daughter processor card, but that in itself is only a €30 component if that failed, and that's basically mail order next day kind of thing. And all of the components used are very readily available. I have support, I have circuit diagrams, I have software support. I've got pretty much everything that I would need in the event of a problem. And under an absolute worst case, if all of these cards were to, for some reason, completely fry, the whole lot costs about €300 to replace. So it's been some of these considerations that have kind of finally pushed me down the avenue that we're going to be taking now, which is we are going to repurpose the power electronics, heatsink, enclosure, connectors, and as much as we can from the original DMOC, but we're going to replace the brains per se with our open source inverter hardware. And just taking a very basic look at what we're going to be doing here, it's not actually that difficult. We'll be replacing the logic board, which is screwed up inside the casing here, which I'll show you guys later, with our logic board, which is much smaller, but we can just make a adapter board out of a bit of copper clad card and just screw that in there. We'll do a similar thing here to replace the God, I'm tired today, gate driver PCB with our 3 individual gate driver cards. These have been modified with a different gate driver chip, which I'll explain later also. And I hope to be able to reuse the existing current sensors. Looking at the current sensors, they look very like Lemhaas 800p sensors, so I'm going to have to whip this board off so we can see what they are and do a little bit of reverse engineering on the current sensor card here, which goes in on this IDC plug here, so we'll be looking at that in greater detail. We do have our own current sensor card, which is based on pretty much the same principles that we sense the currents in 2 phases, and in software then we can derive the 3rd phase current. Unfortunately, the spacing between the 2 Hall effect current sensors is not compatible with where the phase cables go in through the glands here. And what I want to try to do is to avoid any heavy engineering here, like cutting, drilling, tapping, redoing things, because where possible I want to reuse as much of the work that has been done on this inverter as possible. So that's enough of me talking crap as usual. why don't we get straight in here and do a little bit of a tear down. So I've already disconnected what I believe to be a power connection here from the edge of the gate driver board, and I've removed this rather substantial earthing strap. And finally there's something that looks like a 36-way IDC plug on a large ribbon cable. So that should allow me to remove the lid, complete with the logic board, from our DMOC, which indeed it does. And there's some bits in there that we'll go into greater detail with, but I should also be able to then remove this amp seal connector and replace it with a one that I just purchased, which we will then wire to our own specifications. An amp seal connector here, unfortunately, it's a right angle one, but so we should be able to just replace that pretty much straight in there, like for like. So that is the plan, folks. And I guess you guys get to see whether A, I screw up, or B, actually have a bit of success. So the first thing I want to do here for removing the let's get rid of this guy. Oh, it's going over already. Alright. So the first thing we want to do for removing our my God, really losing it, must be Alzheimer's, gate driver board, sorry, is to unscrew. There are some 5mm hex bolts going through the laminated bus bar into the IGBTs. That's one out. I would imagine that these gate drivers are doing DSAT detection on the IGBTs. If not both channels, then certainly one channel, which would be a good idea, but unfortunately we don't have the hardware to implement that at present on our current design. But not to worry, as they say. So that's those guys just loosened off, and fortunately the gate terminals on the transistors are push on, so we should be able to just use a long nose pliers, just pop those guys off in theory. Oh yeah, there we go. There's some off. They're quite tight. We should be able to reuse these push-on terminals, and interestingly it looks like our Azure friends weren't too concerned about the proverbial question over having long cables going to your IGBT terminals, gate terminals that is. Now we've also got two small plugs here. There looks to be two thermistors for heatsink temperature sensing, which is good. We will probably only be still using one of them, but what I might end up doing is using one for the controller and maybe one to drive a temperature gauge in the car, which would be a neat trick. I could just connect it straight out on some spare terminals on the amp seal connector. So we're just removing the gate and emitter, Kelvin emitter I should say, connections, come on the IGBTs. Okay, that's those guys disconnected. So I'm wondering as well, I put a post about this on the EVTV forum, see if anyone might have some circuit diagrams for the DMOC 645. So if you do, answers on a postcard please folks, would be very helpful. So So I'm just removing some Phillips screws now from the PCB supports where they screw into the heatsink, and this should let us remove the gate driver card complete with the PCB pillars, because what we'll be doing is be using probably a little piece of polycarbonate or something like that to make a dummy board up that we can then mount our own gate driver cards on. Then reuse, as I say, the existing hardware wherever possible. So what this will also give me, I don't know, may end up trying to sell them or not a complete set of DMOF cards, but I'll probably hang on to them for a while and see if I can do a little bit of reverse engineering on it. But God knows these days I don't have time to scratch my own nose, let alone do any kind of fanciful projects. But we're here and we're building cars, so what the hey. Last screw here now. So this screw also has a little cable, kind of a tidy thing on it there. Let's pop that in there. We should now be able to just lift away that gate driver card, which we kind of can and kind of can't. Just got it cleared there now, but there's some cable ties there holding that, whatchamacallit, the oh, there's the water colours. God, I really am going nuts today. Holding the heatsink temperature sensor wires onto some of the gate drive wires. I'm going to just snip these little cable ties. So not one of the most exciting videos, I'm afraid, folks. Even less exciting ones on the way. Nonetheless, we've got to start somewhere with this project. So there is our gate drive. I'm going to bring you guys around on it. See if I can get you guys a slightly better angle than that. There we have our gate drive card in all of its complexity. There is some silkscreen writing on there, which is useful. It would be somewhat interesting for me to try to perhaps reuse this card with my own PWM signals. That would be quite interesting. Looking at it, I'm not 100% sure. I'm seeing some familiar components there. I think these white devices here may be Avago gate drive chips. There's probably some isolated power supplies going on here, I would imagine, for the various components to some magnetics, be again for little switch mode converters. But that's going to be a job for another day. So in the meantime, our primary goal here will be to, as I say, just make some material up to replace that card with, so that we can kind of reasonably replace our own gate driver cards in here to control the chips, or the IGBTs, sorry. So I am going to sign off with that before I bore everyone completely to death, and we will come back when we have our new gate drivers mounted on here, and we will also then start having a look at our current sensors. I may have to do some disassembly here on the main capacitor bank, etc., which I don't think will be too tricky to do. We should be able to make that happen. Just checking here, can I get my hex key in? And I think I can. So we'll have a look at this, and we'll be back soon, folks, but this is the start of our inverter build up, so stay with us, and as usual, thanks for enduring my videos, and thanks for watching.